Unit 7 is the last test. Okay, so you're going to take that on Friday. Next week, we're going to start reviewing. I'm going to be honest with you. That review guide, I'm not going to get through every single question on that review guide. So I would start working on it. The videos have already been posted onto eClass. So you can go ahead and start working through it. Okay. But I'm going to basically do a quick synopsis of everything we've learned this semester next week. And then we'll work through a couple of problems. And then you'll take your final exam. And we'll talk about the final exam schedule next week. Unit 7 will be on your final exam. There will be 3 questions. Okay, cool. So is set A mean less than or greater than or equal to set B? And the standard deviation, is it the same, greater than, less than? And how would you figure this out? So if we're trying to find the mean, what we're going to do is we're going to open up Desmos, right? Okay, and so for each dot, that's going to represent 1 point. So there's going to be 1 point, that's a 10, then a 15, then a 16, then an 18, 18, 18, 19, 19, and then 20, 20. We're going to type that into Desmos. But first we're going to type mean, put the parentheses, and then type the number with the list. Okay. One thing to note, I cannot tell you on the test how to do the mean and the standard deviation. You've got to know how to do this. That's why I'm going over it. That's why I'm showing it to you. So the mean for the first one is going to be 17.3. Let's go ahead and do the standard deviation. Remember, standard deviation is STDEV. And that's going to give me 3.02. 3.02. And now we're going to go back and look at our list, the next one, and write that out, and then put it into Desmos. 10, 13, 15, 16, 17, 18, 19, 20. And I'm going to go into Desmos, and I'm going to type it in. That's going to be 10, 13, 15, 15, 15, 16, 17, 18, 19, 20. So the standard deviation for this guy is going to be 2.94. And then the mean is going to be 15.8. Okay, again, you have to know how to type this in by yourself, no help from me. Scroll down so you can actually see it. Okay. I'll give you a second, I'll write that down. So which one has a higher mean? Which one has a higher mean? The first one or the second one?
I'll be honest, set
A. Set A has a higher mean. All right, what about standard deviation? Which one's bigger? Set A, right? Okay, so it has a higher mean and it has a higher standard deviation. Now, without actually having to calculate all this junk, could we kind of figure that out? Not really. I mean, the range is kind of like, they're spread out, but this one's a little bit more squished together just by like 2 or 3 points. It might be best practice to go ahead and make sure that you put this in Desmos if you are unsure. Okay. All right, number 2. A volleyball team has a mean serve of 532 serves in a season with a standard deviation of 35. If the serves for a volleyball team is approximately normal, about 95% of the data falls between which 2 values? So on this one, you have to write a normal distribution. Okay. So the first thing you're going to do is draw a vertical line. You're going to write the mean, which was 532. And then you're going to draw 4 lines to the right and then 4 lines to the left. Okay, so 1, 2, 3, 4. And on the other side, 1, 2, 3, 4. So on the right-hand side, we're going to add the standard deviation. The standard deviation is 35. So that's going to give me 567. I wrote this a little too small. Wait, pause. Yeah. Okay, so it's going to be 532. This is going to be 567. This is going to be 602. It's going to be 637. And this one's going to be 672. Yep. On the other side, we're going to subtract. Okay, so we're going to take 532 and we're going to subtract 35. And that's going to give us 497. Next one's going to give us 462. The next one's going to give us 427. And the next one's going to give us 392. And we're going to draw our awesome curve that looks like Stone Mountain all of a sudden. Okay, so these are the numbers, the ones in the black up on the board. Those are the ones that you need to have memorized. They are also on your formula sheet. If you forget it for some reason, they're on your formula sheets, but you need to know where they go. The mean is going to be the middle number, and 34s go on each side. Now we're trying to find 95% of the data, but when we go 2 standard deviations away, that's going to be from 462 to 602. So 95% is 2 standard deviations away from the mean. Okay, so the range is going to be from 462 to 602. Yeah. Yeah. So you just have to memorize 1, 2, 3, 4 numbers. Yep, and then you just do it on the other side. Yep. Nothing too crazy. Right. On the next one, we got a mean score of 80 and a standard deviation of 7. If a student's actual score was a 92, what's their Z-score? Remember, this is just using the formula. So we're going to do Z-score equals X minus mu divided by sigma. So this is going to be 92 minus 80 divided by 7. So we're going to do 92 minus 80, and then we're going to divide it by 7, and that's going to give us 1.71. You always want to go 2 decimal places, because when you have to use the Z-score table, you're going to have to use 2 decimal places. So if you need to round to 2 decimals. Dodgers baseball. Team has a mean batting average of 200 with a standard deviation of 40. Assume the batting averages are approximately normally distributed. What is the probability of selecting a player with an average over 350? So what you want to do is you can draw your normal curve. So again, we start in the middle and we write out the mean. So that's 200. And then we're going to draw 4 lines to the right. 4. And then 4 lines to the left. You know what? Just let me live my best life, Chris. Let me have this. Okay, so we're going to take 200 and we're going to add 40 to it. That's going to give me 240, 280, 320, 360. On the other side, we're going to get 160, 120, 80, and 40. See, if you just believe, it will fit in. Boom. All right. So, you know what? It's fine. So is 350 listed down here? No. Okay, so what we have to do is find the Z-score and then use the Z-score table. Okay, so we're going to plug in and we're going to get 350 minus 200, and we're going to divide it by 40. $350 minus 200 divided by 40. Oh, you said 150. I heard 50. I was like, that's wrong. What? All right, so we have a z-score of 3.75. The next thing that you're going to do is you're going to go into your table and you're going to look for 3.75. So if you turn to page 20 in your packet, you've got your table. You go down to 3.7. You're going to go over to 0.05. That's going to give us 0.9991. Now we want something that's over 350. This would be under 350. So in order to get over 350, we're going to do 1 minus 0.991. What is that going to give us?
1 minus that.
1 minus 0.991.
You know, I think it's 999 euros.
This is what this is 0.9. Yeah, that's math. Okay. So what does that actually mean? Yeah, I did it right. Okay. So that means that it's going to be 0.09%. How many of y'all play baseball? Okay, cool. Batting average, what's your normal batting average? What's a normal batting average? Yeah, I don't believe you. What is an MLB batting average? 0.25. Okay, so 0.350 would be in the top percent, right? Roughly. So how many are actually going to be able to do that? 0.09% of the people. Yes. That's unlikely to happen, but it does happen occasionally. Okay. Now on this next one, it says, what percent of Dodger players fall between 190 and 260? What you got to do on here is you got to find the z-score again for each one of these. Then find the probability and then subtract because they're asking between. Okay, so we're going to do 190 minus 200 divided by 40. And then we're going to do 260 minus 200 divided by 40 and see what our z-score is. So 190 minus 200 divided by 40. That's going to be negative 0.25. And then 260 minus 200 divided by 40, which is going to give us 1.5. So next we're going to go into our table and we're going to look for these points. So for the first one, we're going to get 0.40129. 0.40129. And on the second one, we're going to get 0.93319. We're going to subtract these two numbers to get our final answer. Okay, so this is the z-score. This is what we pulled from the table. And same thing over here, z-score, table. And we're going to subtract these two things. So that's going to give me 0.93319 minus 0.40129. Which is going to give us that's going to give us 0.5319, which is 53.919%. Ta-da! The superintendent at a school system wants to know how her teachers feel around the county. County has 2,500 employees. What is the best way to collect data? This question on your test, the keywords that you're going to want to look for are randomly selected. Okay. And you're going to probably look for, if they want to ask how each teacher feels, they would probably want to do what type of method. Like, would they want to do a experiment, observation, survey? What would they do? Survey, right? What would be the best method for the superintendent to select 100 people for the study? So they would probably do a survey on this one. In order to pick 100 people for the study, they would probably number the employees, which they already do that in the first place. And then they would want to make sure that they pull cluster sampling. And the reason why I say cluster sampling is because each school is a little different. How somebody feels at South Gwinnett might be a little bit different from how they would feel at North Gwinnett. Does that make sense? There is a North Gwinnett. And Emily conducts an experiment to know the effects of eating a mint candy before taking a test. She selects 10 of her friends to take an exam while having eaten a mint, another 10 of her friends to take an exam with no mint. How should Emily have chosen her sample instead? Well, there's definitely going to be some type of bias with the fact that they're all her friends. So she needs to pick people outside of her friend group and randomly select it. Okay, when we talk about randomly selecting, what I would do is, let's say for this class, I would each give you a number, and then out of a hat, I would pull out numbers. And whatever numbers I picked, those would be the groups. Okay, let's talk about the word bias. If I say something is very biased, that means that it's going to be one-sided or directed towards like a certain group of people. Okay, so write out a situation where a survey would be biased. This would be like on school behavior. Okay. Okay. So how would I write that survey out? Like what kind of question would be that? Mm-hmm. Despite, okay, so like something like, is a certain school, insert school here, a good school to send my kids? And you would say something like, despite the fact that all this craziness was happening, and you would list that out. Because that would gear people towards a certain answer. Because if I said, despite all of the fights that we've had, is this a good school? That already. So the basketball team is separated. Basketball team is separated into two groups of 10, each at random. First group is asked to focus on free throws, and the second group is given no special instruction. At the end of the month, the stats for each players are given for free throw shots. The mean for the first group is 35, and the second is 25. The difference of means is recorded below. What is the most reasonable conclusion for this data? Is there strong evidence, no evidence, or is there difference likely due to grouping?
Listen,
Yeah.
when somebody get ready, you think they'll take their car?
Oh my God. Okay. So what is the most reasonable conclusion for this data? Well, they told the first group to focus only on free throws, right? And then they told the second group to do whatever. So there's the difference between the two, right? So is there strong evidence, no evidence, or is it likely due to grouping? So likely due to grouping. And because they focused on one thing, they got better at that thing. It's kind of like when you go to practice and your coach is like, okay, we're going to work on this today. And then in the game, hopefully you got better at that. Okay, so on this first one, it says, what is the best way to ensure that when picking from a population, you get an unbiased and random group? Okay. You want to make sure that you are strategically randomly selecting. Best way to do this is going to be a random number generator. And what I mean by that is, again, I give you all a number, and then I go to a random number generator, or I pick numbers out of a hat, and that will be my group. Okay, that would be unbiased because I don't I don't know who's getting picked and who's not. Okay. On the next one, it says write a transformation for an absolute value function with a vertical shift up 6 and a reflection across the x-axis. So remember, absolute value looks like this. And a vertical shift up means that we're going to add 6 on the outside. And that reflection across the x-axis is going to make that negative out front. There is one question on piecewise functions on this test. Okay, so this is kind of like a blast from the past. What you need to be able to do is it's going to ask you to write a piecewise function based off of a scenario. Okay, so you also need to make sure that you know what each of these things mean. Remember, if something is equal to, it's going to have a line underneath. If something does not have a line underneath, it's not equal to. Okay. Quick, on your test, you have about 10 questions on your test. There are 2 questions. These are from the previous unit. So one is writing the transformation of the absolute value, and then one is writing the piecewise function. Okay, so you need to make sure that you got those 2 things down. The rest of it is all over that unit 7. Okay, you are taking it on Friday.